Good afternoon. Thank you for joining today's webinar. My name is Bernard Parsons, and I'm the CEO of Becrypt, and I'm joined here today by Harshad Tokay, our Chief Architect. So we're going to provide an overview of work that we've been doing over the last 2 or more years, work with government and funded by government towards the development of a novel cross-domain solution, which is called Hitman. And Hitman is best thought of as an API-Centric cross-domain solution. We are going to kick off this afternoon with some slides. We're going to start with an introduction to the work we've done, and that's primarily going to talk about the drivers, the original drivers behind the project. And then we're going to go into a bit more of a deep dive into the technology itself. And then we're going to cover a number of use cases and talk about the architectures that were implemented to support those use cases, really as a way to provide an example as to how the requirements were met. It's quite a technical presentation, but with Harshad here, we're quite happy to go into more technical detail in response to any questions. So please feel free to drop questions into the chat online. We'll try and process those as we're going through, so you don't feel the need to wait to the end, but there will be some time at the end to have Q&A. So I think the slides on their own probably run for about 15 to 20 minutes. So we'll have plenty of time to dip into either more technical Q&A or non-technical Q&A if you'd like. So in terms of the project drivers, I've put these into 3 buckets. And really what we're doing here is we're reflecting and hopefully articulating accurately what our government colleagues saw as being the drivers. And the first is very much about the threat. So the view was there's an increasing amount of data that is crossing between different trust domains or needs to cross between different trust domains. And for many architectures, a lot of that data is going to sit unprotected within an organization's DMZ. And as a result of that increased volume, and therefore the increasing amount of risk, it was government's view that that risk was no longer acceptable. It's no longer sufficient to have architectures where the high assurance gateway is just doing inspection. So the challenge was, what can we do about implementing protection, particularly in low-side systems? How do we protect low-side data, address data aggregation in architectures? How do we bring together encryption and inspection in the same gateway platform? The second is around the environments. So the way that we look to integrate applications and services either within or across trust domains is far more dynamic today than it was perhaps 10 years ago. And so the primarily unidirectional data transfer paradigm that a lot of the kind of CDS world grew up around is no longer the best fit for a lot of the requirements that are emerging. And then the last is around customer needs. So our customers needing to be able to develop applications and services rapidly that are compatible with cross-domain architectures, but also to be able to make use of ecosystems of developers that can do that without being tightly bound to the CDS suppliers themselves. And lastly, to have architectures and patterns that are created through this work that are themselves reusable across the community. So very quickly, the use cases that we're going to cover today is, first of all, management system isolation. We're going to talk about protecting file browsing into high-side systems from other trust domains. We're We're going to talk about calendar synchronization as an example of service-to-service interaction. And then we're going to talk about structured document import, so things like Word document, and using content disarm and reconstruction functionality in conjunction with a CDS. So as I say, those use cases should give us the framework to illustrate how architectures were implemented to address the project requirements. So with that, I'm going to hand over to Harshad to go into more detail around the technology itself.
Thank you, Bernard. So yes, Hitman started almost 3 years back, and the name Hitman stands for that. It's an acronym which stands for High Threat Messaging Across Networks. The name came first, but it did have a real basis in terms of the problems that the government was facing. This was all around trying to around the dynamic sharing of data, being able to interact with different trust systems very frequently, and it was at that time envisaged as some sort of originally a messaging system. And this addressed low latency and high frequency messaging. So where this came from originally was to try and address collaboration use cases like email, Rocket Chat, and file browsing. Those were the 3 original use cases. So when we looked at creating a cross-domain solution, our government colleagues asked us to consider how we'll fulfill real-world use cases with this. And this is what led us to select REST APIs as the basis for Hitman. So what we said is all of these use cases can be enabled if we can support REST APIs as a generic framework. And this goes back to what Bernard was talking about, creating reusable architectures and patterns. That's where the name came from, and that is what this architecture is all about, which we'll see in a bit more detail on the next slide. Yes, so looking inside the box a little bit, this is what the Hitman architecture looks like. We'll look at this diagram starting from the left-hand side, going towards the right-hand side. The left-hand side is an app, typically living on a remote device, endpoint, a phone, tablet, or something that's consuming information. That's calling into, now we move into the appliance itself. The appliance has a black side that runs a web service. It can handle web-based requests, which is where most of the modern apps, REST-based apps are. That then sends that data to a hardware-based component that combines the decryption and the syntax checking at an FPGA level. This decrypts the data. This encryption is an additional layer on top of HTTPS. That means the entire API call, its parameters, and the application payload, everything is protected. This allows you to run APIs with the confidence that nothing on the black side, nothing on an individual app, or the arrow that connects the app to the black side, none of that's going to really see any of your API contents. Once it's decrypted, XML syntax checker will make sure that this is good XML. This is a syntactic checker. It's just making sure it has good XML. And once it's done that, it passes it on. Then what we added is on the red side, we added XML validation. This applies semantic rules. So it not only says this is XML, it says, is this the XML that I expected? Are my nodes in the XML correct? Are the values in there the correct range? If I expected a Boolean or an int, is that where it is? And those rules are specified by the developers and enforced by Hitman. Hitman also then allows separation of different applications and supporting different applications. So you can have one application using one set of APIs and services and another using another, and each of them will get their own rules. And then the Hitman curl HTTP client is the last step, where Hitman effectively behaves like a client and talks into the server. So if you take a step back, this model looks like an API gateway. Today's Amazon API gateways, Google's API-G, and others follow a similar pattern. It's not exactly the same, but it's quite similar. And the reason to use that as a conceptual equivalent is because that's something that most application developers, most SIs, and others developing today's applications will be able to relate to. And then the last bit is this Hitman management layer at the bottom that effectively allows a single pane of glass that manages all the three components that you see on the top, so that all the configuration is centralized and it comes in a nice, lovely appliance. And the last one on the right-hand side is the server. That's unmodified, that's unchanged from a service perspective. Hitman is entirely transparent. So that is, in a nutshell, what the Hitman's simplified architecture is. Over to, I think, looking at some of the use cases. Back to you, Bernard.
Great, thank you, Harshad. So we'll start off with the management system isolation use case. So this is all about being able to place your device management platform behind a high assurance gateway. So the assumption is, or at least the aspiration should be, you trust your core network a lot more than you're going to trust some of the devices that it's managing. And so what we're demonstrating here, and the key part of this, is that all of the management traffic for the devices that are being managed here are passing through the Hitman gateway. So that allows us to validate, as Harshad was just explaining, the messages are both well-formed messages, and they're exactly what the device management platform is expecting. So effectively protecting the management platform at all layers of the network stack from an attack through this vector. This is a pattern that is now a standard pattern for a number of secure networks within government and defense. And really, we're calling this out as an example of a requirement for dynamic interaction. So what we've got here is a management platform that's exposing APIs. So this is a scenario where we want frequent small messages being communicated across this infrastructure with low latency. The other thing we're calling out on this diagram is with the credential symbol, the fact that the team also have done some work around being able to pass certificates and keys safely across domains. So one of the characteristics, one of the properties of the current implementations of Hitman is that the data that is validated by the gateway is not modified. So that allows you to safely pass things like digital certificates, which are problematic in some CDS architectures. And then the last thing this is calling out is support for device authentication and being able to, again, pass device authentication protocols across a gateway. So that allows you to not only have confidence in what's connecting into your high-side network, but other protected services. And then very quickly, we've got another simplified architecture, again, in the context of management system isolation, just demonstrating here that the same can be achieved with mobile devices. So again, the key thing here is we've got a gateway sitting in front of the MDM platform. So you can put your high-value MDM within the core network. This architecture required us to implement a series of proxy servers because we need to be able to talk to the smartphone ecosystem, things like Apple push notification services and so on. But we can terminate proprietary communications from that ecosystem in the DMZ with something that appears to the external world to be an MDM, but it's just a proxy server. And then we can validate the traffic that we allow to pass on through the gateway to the high side.
Yes, so this is another use case. This comes from government aspirations of allowing the government workers in various places to use mobile phones as we use it in the commercial world today. On our phones, it's very usual to get emails, look at documents, chat to your colleagues on the phones. What this particular use case was to enable similar usage of the phones, but at higher tiers of data classification and higher levels of sensitivity in a safe and reasonably risk-free manner. It's not entirely risk-free, but it's reasonably risk-free. What this shows is an application called a secure file browsing. It allows you to browse files that are held on the high side. Initially, the application is enrolled, which is the top stuff, that the top boxes that you see over there. This registers keys and identifies and associates a device with the user. Once this has been done as a one-step process, then it's the bottom boxes that come into action, where a user can look for files, browse through directories, and select them. This is controlled via the release control service on the right-hand side. And once the release control service deems that these files are A, appropriate to be released to mobile, and B, allowed for the user to access, then they get individually encrypted for that device, such that if any other device came in, any other attacker came in, what they would get is a file that they cannot decrypt. That's what's there in the cache, but it gets released to the device, and then the device can read the files. Yeah. Since they're individually encrypted with single keys, they can be thrown away separately. And over here, what Hitman solves is the data aggregation issue when you're calling via Hitman, because when you're implementing applications like file browsing, you can have folder names that are sensitive, file names that are sensitive, or search terms that are sensitive. Those are all the risks that you would incur on the low side of the DMZ, which get protected via Hitman. And all of this is perfectly suitable for an API use case, quite a bit like Dropbox people have and are used to having on their phones.
Thank you. So that takes us on to an example of service-to-service interaction, automated interaction. And we are using the calendar synchronization use case as an example of that. So we've got a high-side service that can interact with the high-side calendar, but also communicate via the gateway with the low-side service. And this is solving the problem that low-side users of multiple trust domains have, where they can't access the calendars in one trust domain from another. So they never know how to coordinate their diary entries. This allows for a defined set of information, like free busy periods, to be released from the high side. But again, what this is utilizing is the Hitman capability of validating that the message format and message content conforms to the rules that are implemented for this architecture. So this is an example of machine-to-machine, but also an example of rapid application development. So this was highlighted as a requirement by one of our government organizations that we've been working with, and I think a prototype was turned around to demonstrate this capability, reasonably complex capability, in something like 3 months. The other thing to call out that was solved as part of this project was mapping identities between different trust domains. And the team worked on the OAuth protocol as an authorization protocol. So a pattern has been established to have OAuth traverse the gateway.
Thank you, Bernard. This is another use case where what we've established is a common architectural pattern for getting complex data via Hitman. What we've built, and over here some of the color coding helps. Anything in yellow is third party. The gray bits come along with Hitman. And these are additional components, reusable and extensible components that we've built. And as you may have noticed through the slides, we've got the reverse proxy showing up in different guises, as that helps. That makes Hitman a bit more transparent. That has been extended to have the capability of now handling plugins. You can have data being sent to Hitman via client or via service, which is there out on the internet, that can be safely disarmed in the low side via the plugin. Hitman will allow you to configure it. Hitman will have all the capability of recognizing this and knowing how to send it off to a disarming service. That data is then sent across Hitman, and Hitman is again now aware of this new formats and new capabilities where it's got a deconstructed and disarmed data that the validator in the top right-hand side of that picture shows recognizes as a special kind of file that is then sent off to a validator and reconstruction element that can be third party. An example of that is Glasswall that we're working with, and that will recreate the document as an example, send it back to Hitman, and then that can carry on to the next cloud server. Again, one of the use cases was you can have documents being dragged and dropped, and they go across Hitman. And then this is a extensible capability, so you could have other content disarm solutions being added into this mix, or some other sort of scanning if that is required for more complicated binary data. So this is an example of the reusable architectural patterns that we mentioned at the start that we are developing along with the hardware solution.
Thank you, Arshad. And so that takes us on to just a summary slide. So in summary, Hitman, we think, represents a novel architecture for dynamic API-based cross-domain applications. Work we're talking about here, I think, demonstrates that patterns and tools are being developed for reuse across the community. And importantly, Hitman supports an independent ecosystem of developers. And the very final slide, last but not least, Becrypt is in the process of marketing a version of Hitman under the brand AppXD. There are two instances of this. There are two target hardware platforms that AppXD currently supports. So it can be ported to other hardware platforms, but that is the current focus of the organization. So that takes us on to questions. We've got a reasonable amount of time to cover off any topics that the audience would like to. So again, please feel free to drop us any questions into the chat box on the GoToWebinar platform. I've got a couple of I've written down as we've been going through, which I'll start off with. So the first one is really just trying to get some clarity, Arshad, this is for you, on why that architecture that was showed on the MDM slide, but why is that justified from a risk perspective?
Yeah, thank you. Yeah, that's an interesting point, Bernard, because quite a lot of people would think that device management can be done entirely on the low side. And for large parts, that's quite true. You are trusting the vendor to provide the device, the software that runs on it, and how things get managed on there. But there is a component of shared responsibility, and that is configuring the device correctly and making sure that it meets your needs and risks correctly. That's where an MDM steps in and provides those controls. Now, if those controls are left in a high-risk zone, you have never got the confidence that they have been applied correctly, or worse, they have been, whether they've been compromised or not. So when the government, when we worked with several government departments, one of the needs that was identified was to keep those aspects of the policy which say that this device is configured correctly as a high side element. And that is what we that is what justifies the architecture that was shown earlier, both for mobile devices as well as for desktops. It ensures that your devices are managed as per the policy that you have in place.
Great, thank you. What would a developer need to be able to write applications? What would they need to have access to? And can you give any examples of where third parties, so outside of Becrypt, have developed anything for the architect for the platform?
Yeah, that is again another very interesting point, because historically cross-domain solutions are viewed as fairly scary creatures, fairly difficult space to engage with, not very well documented, usually requiring some hardware. One of the things that we did right from the inception of Hitman was to put the developers and system administrators first, think about how this will be deployed in the real world. So what we produced is a software-only version of the Hitman architecture. This is the first tool that the developers would use. They can deploy on their laptops, desktops, in the cloud, or on-prem services. So this effectively gives them a software copy that behaves entirely identical to the hardware platforms. It does not have the security enforcing functions and the properties that you would get from a hardware platform, but in terms of the behavior and in terms of the checks that it applies, including all the checks at the XML level, remain the same. That means developers and testers can be confident that they have created a system that behaves well before putting it into production. So developed software Hitman. We also have tools that are called learning tools like Hitman School that help the new developers come on board very easily. So this is not very difficult. It comes with a graphical UI and a graphical Hitman School. That means that it's very easy and simple to interact with Hitman. So those are the bits that we provide, and we have two interesting examples. We work with a couple of other companies to develop solutions. Acubed is a partner with who have developed cross-domain hybrid applications CDHA as a framework, and that was developed on top of Hitman. We gave them the Hitman School, we gave them Soft Hitman, and they pretty much got on with developing the solution independently. An application of that was recently brought to life in one of the other government departments, where we had to take the theory of developing this against a soft Hitman and applying it with real appliance in the field. And we successfully managed to do that for a pilot, where we developed everything in the labs. It was all in software. We took the configuration, applied it in situ in one of the government departments in their data center with a physical appliance, and everyone was quite surprised when it just worked. So we've seen that in action. Acubed is one of the partners we're working with. Shovoin, we're working again with other government departments to port across Rocket Chat. So there have been a number of others who have used Hitman in order to develop their applications.
Awesome. Can you say something about the performance or bandwidth characteristics of the current platforms?
Yes, so one of the things that we have been very conscious about is developing this for low latency and high volume. So we always have, throughout its history, right from the beginning, put in performance checking as a crucial gate right through its development, right through how it's architected. And we have been running performance tests against this, against the physical device. We originally targeted having 2,000 to 3,000 simultaneous devices, things like phones, where you have a mixture of use cases, someone downloading large sections of emails while still wanting to chat. And one of the core requirements was one application should not be able to affect the performance of another application. So we do test with about 1,500 clients continuously as we go through the Hitman lifecycle. So at least from where we are, we think it performs at the required target.
What's the best way of thinking about the protection that CDS provides versus what you can get with a firewall?
That's a good question. So yes, next Standard firewalls will just open ports and they'll say which traffic is allowed on which of the routes. It doesn't say anything about the kind of the traffic. It just says this port's allowed, and anything that can go through that port is allowed through. Various people have known to abuse this to carry across other types of traffic. So standard firewalls are obviously not enough when you're dealing with cross-domain solutions. Next generation firewalls intercept the traffic and do some inspection. But in those cases, the big challenge is around trusting the firewall itself on how the firewall has been produced, how well it has been implemented, and whether that really gives you the level of cross-domain protection that you need. With Hitman, as you saw, what we've got is quite a complex architecture with a black side and a red side that does run on entirely separate CPUs with entirely separate operating systems. So under the hood, the level of separation that's implemented as a part of the Hitman architecture is a significantly higher step than next generation firewalls. And that's just still, we're talking about the software architecture level. When you combine this with high assured platforms, what you get is unlike anything else you would get from the next generation firewalls, because everything from the hardware to the software architecture has been assured and has been designed with a view that the lower trust side of this whole system could be compromised. Typically, when you look at a firewall, the view is nothing in the firewall is compromised. The firewall is your wall, nothing bad can happen. And that's a fairly black and white view, whereas what Hitman takes is a much more defensive view of saying the black side of Hitman can be compromised, and yet everything else should remain in place. And that is what it allows, which means that fairly well-equipped and clever adversaries can attack Hitman, could potentially get to the black side. It's been designed to still defend against that sort of attacks. And I'm not certain if any other firewalls could claim that. Because once you compromise a firewall, you compromise a firewall in its entirety.
Sure. This might be quite a broad question, but I'll see how you get on with it. But what differentiates Hitman from other CDS platforms?
Yes, so that is indeed quite a broad question. So there are several differentiating factors. One of the main differentiating factor, as we've seen, is the extra layer of encryption that Hitman provides, which goes right to the heart of the hardware layer. This is an application layer encryption. This provides the defense against data aggregation and DMZ. That's the main security advantage. But beyond that, what we have, as you've pointed out in the slides created, is a reusable, easy to use, easy to understand, and easy to play with solution that any developers could pick up, try it, and deploy it, and quickly build applications against. So that ethos of building something for today's cloud, something that could be deployed in the cloud, that developers working with cloud-based services could understand, has been there since day one of the product. So in my view, it came from a different place. It came with a different target in mind, and its target, since it's pretty much its inception, has been developers. So right from the day one of its architectures, we had developers in the mixture, and people thinking about how this thing gets deployed, what are the challenges, and it tries to make that easy. So ease of use is the other aspect that I'll bring out. It's not a security aspect, but it's an aspect that makes Hitman stand out as compared to the others, the other CDS solutions, that it's simple to get your head around and easy to use. And then the last bit is we are continuously developing and solving problems. So I'd like to touch upon the bits that you mentioned earlier around credential management and a subset of OAuth protocols that we have enabled. When you look at the CDS space, you end up with the challenge that these are two different domains and you're trying to connect them up. So standard problems that usually are solved problems, such as how do you identify a user? How do you authenticate a device? How do you know who's talking to you? they all become very difficult problems to solve in this space. Normally, you would have boilerplate design patterns to follow in the commercial world, but there's not much in the CDS space, and that's what Hitman also provides, is quite a lot of these patterns and problems that have been solved, and you can solve them easily yourselves if that doesn't fit you. That is how I would see Hitman as being different to the others.
Excellent, thank you very much. I've got one more question for you. Nothing currently else in the question queue. So if anyone does have any last-minute thoughts or questions they'd like to pop in the chat or the question queue for us, then please go ahead and do that now. But I've got a very simple question. I'm sure I missed some things, Harshad, when I was going through the slides that I took. So what did I miss?
The only thing that I would say that I would like to add, not really something that you missed, is the fact that what we are building here is an API-centric solution, really, which deals with how you would carry across APIs through cross-domain. This is quite a challenging piece, but we are pushing the boundaries with Hitman on this one. And for me, that's quite exciting because there isn't quite anyone attacking this problem space and pushing the boundaries the way we are. So hopefully we'll have more fun things to bring to this scenario down the track.
So on that note, then we'll certainly be communicating other webinars and sharing our findings in this world as we continue with that work. Just a reminder, we are currently supplying Hitman in the form of AppXD into government and defence and across the wider critical national infrastructure. So if you've got any further questions or follow-up that you would like to pursue with us, then please don't feel free to please don't hesitate to get in touch. My colleague is just reminding me that we are at DSCI and there will be a live demo of AppXD at DSCI. So please join us. I'm trying to remember what the stand is. I think it's H1337. So yeah, please come along and see us at DSCI for those that might be there. I think we might even have some codes. Do we still have some codes available for? Okay, we've got some codes that expire today. If you are thinking of going to DSCI and don't yet have an entry pass, then please get in touch with us today. I'm just looking around the colleagues that are in the room with me to see if there's anything else that we've missed. So thank you, Harshad, for your time today. That was a fantastic contribution. And thank you, everyone, for joining us and look forward to following up with those that are interested. Many thanks.